A potter's wheel rotates from rest to 210 RPM in a time of 0.75 seconds. What is the angular acceleration of the wheel during this time, assuming constant angular acceleration? How many revolutions does the wheel make during the time interval? Find the tangential and radial components of the acceleration of a point 12 centimeters from the rotation axis when the wheel is spinning at 180 RPMs. From the equation, we get the initial angular velocity, which is 0, and the final angular velocity, which is given through the 210 revolutions per minute, and through a simple conversion, you're able to convert to 7.0 pi radians per second. With the angular initial and final velocities given, and the delta t of 0.75 seconds, you're able to do a simple calculation to get the angular acceleration, which equals the final velocity minus the initial velocity over delta t, which equals 29 radians per second squared. Then you're able to find displacement through another simple equation, which is delta theta equals 1/2 times the final velocity plus the initial velocity times delta t. And by plugging in what you have, it equals 8.25 radians. And then you're able to convert that easily by dividing 8.25 radians by 2 pi to give you 1.3 revolutions. For the final part of the problem, to find the tangential and radial components of the acceleration, you look to find the new velocity at the time. Velocity equals the 180 revolutions per minute, and you have to convert it to equal 6.0 pi radians per second. Then you're able to plug that in to the equations that are constant. So the radial acceleration equals velocity squared times radius, which equals 43 meters per second squared. Tangential acceleration equals the acceleration times radius, which equals 3.5 meters per second squared.